After its launch in December 2013, Gaia began a 5-year mission to scan the skies and map 1 billion stars in our astronomical neighbourhood, the Milky Way galaxy.
Our first release will contain positions of 1 billion stars. So that will allow us to look, what does the night sky really look like when you would look at in random direction with a telescope which can see very faint stars. And a subset of 2 million stars, we will have the distance and the motion. So that is really the basis for astronomical studies. People can really look into details of these sources and study the behavior of the stars.
In addition, Gaia has produced light curves for about 3,000 stars, showing how they have been varying over time, and this will help scientists better analyse the star's internal structure. The first satellite to chart the motions, positions and distances of stars was ESA's Hipparcos satellite. That was for about 100,000 stars. Gaia's task of pinpointing the position and movement of 1 billion stars is unprecedented and will help answer questions about our galaxy's structure, how it is evolving, and how the stars reach their current positions. To do this, the spacecraft is orbiting around the L2 Lagrange point. The Sun, the Earth and the Moon are all roughly in one direction, and the sum of gravitational forces makes it an ideal position to study the stars at the dark side of the sky. After various technical issues were resolved, Gaia is operating at full capacity, continuously performing science and collecting data.
Well, the big challenges are the size of the focal plane, which is roughly 1 meter by 60 centimeters. It's really big, it's 1 billion pixels. The accuracy with which they scan the sky, that has to be very stable. And then the positional accuracy, we want to get down to 10 micro-arcseconds, and that means roughly the size of a coin across the Atlantic.
All the data from the stars is transmitted to Earth using ESA antennas on the S-Track network in Argentina, Spain and Australia. From there it goes to Darmstadt in Germany, where the spacecraft is controlled, and then to an ESA data processing centre in Madrid. The next step is to distribute the data to specialised data processing centres across Europe. After the scientific results are returned to ESA, the detailed information about these stars are released to scientists across the world.
Now that we've released the first data, we continue with the processing, but actually the processing for the second data release already started a number of months ago, so we do these activities in parallel.
The full map of 1 billion stars with distances and motions will be released towards the end of 2017. But the astronomical community will be delighted with the first batch of 2 million stars, in the knowledge that there is far more to come.